In this tutorial, you'll learn everything you need to know about array indexing and slicing. I will show you the basic techniques and some advanced ones. Let's move to our Jupyter Notebook. We first import the library by saying import NumPy as np. Then, let's start with the easiest example, how to perform indexing and slicing of a one-dimensional array. What you need to remember is that indexing Python always starts with 0. But Python also supports what we call a negative index. And what is that? You can always refer to the last element as -1. So the index of the last element is -1. Then you go backwards and then you always decrease 1 unit. If you watched the last tutorial, now you know that we can use the arange function. How you do that? We type np.arange. Then we provide the first number of the sequence. What is that? 20. And the last one, which is 25. Why? Because the arange function, the last number is always exclusive. If I execute this code, we get our desired array. Now, let's access the third element of this NumPy array. How to do that? You just type the name of the array, in this case array 1D, brackets. It's up to you which index system to use. I'm gonna use the positive one. The third element has index 2. If I run it, I get our third element, 22. If I want to use the negative index system, that's gonna be -3. If I run it, we have it. This is quite simple. But what about slicing? Let me just scroll a bit. And here in the top right side is something that you should always remember. When you want to perform slicing, we always give the start index, colon, and the end index. And what is important to know, the end index is always exclusive. Let's practice it. Let's take the elements from 21 to 23. How to do that? We just type the name of the array, array 1D, then brackets. What is our first index? As we want the number 21, that's gonna be index 1, then colon, and we want to stop at the element 23. What is the index of the element 23? So the first one is 0, 1, 2, 3. Okay. As I mentioned, the end index is always exclusive. Then we provide 4. Now, what about if I want to get from 21 to 24? That's easy. I just need to provide then 5. Now there is something important I want to tell you. When you are in this position where you want to get one element and then the rest of the array, you don't need to provide the end index. Python will realize that you want to get a number from the start index up to the end of this array. Let's move to a two-dimensional array. Alright, now we have one additional axis. The index that you're gonna use to refer to rows is the index I, and the index that refers to columns is the index J. Before telling you how to access an element of a two-dimensional array, we first need to create this array. We can use the arange function again. We just type np.arange. Our first element is 1. Our last element is 12. Then I should provide 13 because again it's excluded. And if I run this line, I get a one-dimensional array. To get a two-dimensional array, we're gonna use a method from array called reshape. And now, how many lines do we have here? We have 3 lines and 4 columns. If I execute this code, we get our desired array. To access an element of a two-dimensional array, we also provide brackets. Then, inside the brackets, you give the I index and the J index. Let's access the number 6. What is the I index of the number 6? Is 1. Then I is equal to 1. And J is equal to 1 as well. Let's run it. We get 6. Now let's try to get the number 11. The I index of the number 11 is 2. And the J index is also 2. If I run it, we get it, 11. Now, how can I get the entire column? Let's get the third column. The third column has index 2. It's already there. But what about rows? Which rows do I need to get the entire column? Well, I need to get all of them. Then I should start from 0, column, the last index, which is 2. Then I should increment 1 unit. And if I run it, we get 3, 7, 11. In case you want to get the entire row or entire column, you only need to provide column. If I get all the rows and the index number 2, I'm gonna get the third column. Then how can I get the last column? I provide 3, 4, 8, 12, or I can use the negative index, then I provide -1. Let's select the second row. Okay, what is the index of the second row? Is 1. And if I want to get the entire row, I need to select all the columns. How to do that? I just provide the column symbol. If I run it, we get the second row. Let's move now to a three-dimensional array. On the top left side is basically how NumPy represents this three-dimensional array, and then we have this sketch to better explain what's going on here. As it is a three-dimensional array, we have 3 indexes: I index, J index, and the K index. First, how to create this array? Let's use again the arange function, np.arange. Then, what is the first number? My first element starts with 1, the last one is 24, and I provide 25. If I just run it, that's going to be a one-dimensional array. Then you can create a three-dimensional array using the reshape function. And what should I provide here? This three-dimensional array is composed by 2 two-dimensional arrays. The two-dimensional arrays have 3 lines, then 4 columns, right? Here I have 24 elements. If I multiply 3 by 4, I'm gonna have 12 elements. There is something missing. What is that? Is the last axis. In this case is I. And for a three-dimensional array, the reshape functions reads like that. You provide the I index, the J index, and the K index. How many two-dimensional array do I have? Well, 2. Then we have the JK index, which is basically the row and columns indexes. If I run out this code, we get our array. Let me just scroll a bit to show you that this array and this array are exactly the same. All right, now let's select the number 6. For a three-dimensional array, we need to provide the I index, the J index, and the K index. What is the I index? The blue dimensional array is the first one, therefore it gets index 0. Now we only need to look at the J and K indexes. It's exactly what we saw before. The J index is 1 and the K index is also 1. Then I provide 1, then 1. If I run it, I get the number 6. Let's now get the number 19. The green array, which represents this second array here, has index I equals to 1, correct? Then I want to select the number 19, therefore my J is equals to 1 and the K index is equal to 2. And there we are. Perfect. Now I have a challenge for you. Your task is to slice this three-dimensional array using the green two-dimensional array and take the numbers 14, 15, 16, 18, 19, and 20. Please try it, and after that you come back to the video and then I show you my solution. Alright, the green two-dimensional array has index 1, correct? Then it's already there. Now, which rows we need to use? We need to use rows index 0 and index 1. Alright, then I give here our column, which goes from 0 to 2. And what about K? K should start from 1 and end in 3. And here I have 2 options. I can either give the number 4 or I don't need to provide it, right? Then if I execute this code, we get our answer. Now I'm going to show you how to have more flexibility when slicing a NumPy array. Let's say I want to get the first and the last element of this one-dimensional NumPy array. I know how to select the first one. I just provide 0 as index. I also know how to select the last one. I'm going to use negative index here. But we didn't talk about how to select both. When you want to provide more than one index, the only thing you need to do is to provide a NumPy sequence. And this could be a list, a tuple, or even a NumPy array. Let me show you how to do that using list. I want to get the first element and the last one. If I execute this code, we get it. Let's also include the number 30. That's easy. I just need to add comma, then the index 2. And if I want to have the number 30 at the second position, I just need to use it in the second position. Alright, what about two-dimensional array? This is no different. We provide the brackets, We have a list for the I indices, then a list for the j indices. Let's now slice this NumPy array, getting the numbers 10, 70, and 100. What is the I index of the number 10? Is 0. What is the j index of the number 10? Is also 0. Then, comma. We do the same for the number 70. The I index is 1, and the j index is 2. Then finally, we have the number 100, which has I index 2 and j index 1. If I run this code, we get 10, 70, and 100. Let's talk about what I believe to be the most powerful advanced indexing method, Boolean indexing. We can apply a conditional statement to test the elements of NumPy array. Let's check what are the elements greater than 40. Here I can just test array greater than 40. If I execute this code, what I get is a NumPy array where all the elements are mapped to either true or false. Here we see that 10 is not greater than 40, 20 is also not greater than 40, but 50 and 60 are. You saw that we can apply sequence indexing to slice an array. So what we can do, we can use the result of this conditional statement and apply a slice. What we're gonna get is a slice with all the elements where this conditional statement is true. Then we get 50 and 60. Now let's slice this two-dimensional array and get only the elements which are greater than 70. First we create our array, then we can test. And what is our test? The elements which are greater than 70. Now we can use this array to slice this specific two-dimensional array. How to do that? We write array 2D, then we provide the Boolean indexing. If I run it, we get it. Boolean indexing is a very useful and a must-know technique not only to deal with NumPy arrays, but also with pandas data frame. And that's it for this indexing and slicing tutorial. Thanks for watching.